Hello everyone, this is the final year project. Our project name is Enhancing Fuel Station Operations, a user-friendly mobile integrated system for accurate dispensing system. I am Veera Hemant Kumar and my teammates are Sai Tendulkar and Ashwant Sai. Our project mentor is Anita ma'am. The objective of our project is to modernize and streamline fuel station operations by integrating automation, precision, and secure payment solutions. The system enhances operational efficiency and customer satisfaction by following key features. Accurate fuel dispensation. It ensures the precise fuel measurement and delivers minimizing wastage and reduces the human error in the fuel station. Secure payment integration. It offers seamless and cashless transaction experience via QR code and mobile payment systems. Automation and user-friendly design it includes automated process such as a pump activated through QR code scanning when the payment is done, and it is real-time transaction monitoring. Correct. Current petrol pump systems sometimes leads to inaccurate fuel measurements because of manual operations causing dissatisfaction among users. This proposed system introduces automation and mobile integration to enhance accuracy and provide a better experience for customers. The users can register on the system using their mobile phone, authenticate via OTP, and select the amount they need. A QR code is generated for their order, which activates the fuel pump automatically when scanned. This ensures accurate fuel dispensing without any human error and build trust in the process. Payments are made through an Android app, providing instant notifications and digital receipts for the convenience of the user. By merging mobile technology with petrol dispensing, the system improves efficiency, transparency, and reliability, meeting the needs of modern customers. This is the literature survey of the previous paper. Hardware requirements of this project are power supply, Arduino Uno, ultrasonic sensor, IR sensor, GSM, OLED relay, solenoid valve, ESP8266, motor drive and pump motor, and the keypad.
Software requirements: Arduino IDE, Embedded C, Android Studio. So the proposed automated fuel dispensing system integrates with mobile registration and OTP authentication and QR generation for streamlined user interaction. And the user selects the fuel level via an app, activates pump with QR codes, and completes the payment digitally. So this is the block diagram of the proposed system. First thing is keypad, used by the user to input the desired fuel quantity and other commands. It sends the data to Arduino for processing. Second one is ultrasonic sensor. It measures the fuel level in the tank and the quantity which is dispensed. It also ensures accurate dispensing based on the user input. And the third one is IR sensor. Detects any obstacles or any misalignments in the system and nozzle positioning or user presence. It also provides feedbacks to Arduino. And fourth one is OLED. It is also a display, shows important details such as instructions, fuel quantity, cost, and payment QR code. Helps in user interaction. And the fifth one is motor driver. Control the pump motor speed and direction to ensure the correct amount of fuel to be dispensed. And the sixth one is pump motor. Drives the pump to transfer fuel from the tank to the nozzle. And relay. Relay acts as a switch to control the solenoid valve or other high powered devices. And ESP8266. It is also a Wi-Fi module, enables communication with mobile app and server for user authentication, OTP verification, and it also gives the real-time updates and notifications. GSM module. It sends the SMS alerts or notifications to users such as transaction confirmation and system updates. And the final one is solenoid valve. It also regulates the flow of fuel by opening and closing based on system instructions from Arduino. Here is the flowchart of the proposed work. Firstly, user registers and authenticates via OTP. Next, user will select the required fuel quantity, and then the QR code will be displayed by a OLED display, and later on user scans the QR code and completes the payment. If the payment status is okay and if it is successful, then it will activate the pump. If the payment is failed, then it will not dispense the petrol, and after verifying the payment status, it will dispense the petrol and monitor dispensation using sensors. After this process, it will stop the dispensation and notify the user and provide a receipt via mobile and SMS.
These there are three modules. One is fuel dispensation module, payment module, control and monitor module. Fuel dispensation module. This module controls the solenoid valve will pump the motor to dispense the selected amount of fuel. It ensures the accurate fuel delivery based on the user input via keyboard. Payment module. This module displays a QR code on a LED screen, enables to secure payment through mobile device. It integrates with a digital payment platform to perform the transaction and confirm the payment. Control and monitoring module. Managed by the Arduino Uno, this module oversees the entire system operation, processing the user input, activating the fuel dispensation mechanism, and monitor the system performance. It ensures accurate fuel dispensation and manages the system alert or error notification. The output of this project, the image displays the entire hardware sector of the user-friendly fuel dispensation system. The system combines Arduino microcontroller with relay module, solenoid valve and keypad input, and OLED display, and sensors to automate the process of the fuel dispensation. This dispensation mechanism can be observed through a pump and fuel transfer system components. The OLED module in the image shows a special QR code for the user to scan in order to finish the authentication process. The system uses a QR code based on the system method to stop unauthorized access of fuel, which leads to better reliability along with reducing the fraud occurrence. Mobile application payment screen allows user to finish the transaction by filling their details along with the email ID and credit card information, includes the number and expiration date and CVV. The payment gives the user both enhancing transaction security and a simplified payment method. The mobile application will show the payment confirmation by showing that payment process was successful as shown in the picture.
So this is the real-time database of the output. This image displays the Firebase real-time, which securely stores transaction details such as amount and the payment status, date and timestamps, ensuring real-time updates, secure payments and reliable data management. This is the overall hardware setup of the proposed system. Conclusion. Enhanced fuel station operations combines automation, precision, and secure payment solutions. It improves efficiency and user experience. Accurate and secure dispensation. The Arduino Uno based microcontroller ensures accurate fuel dispensing, minimizes human errors and operational inefficiencies. Cashless and convenient payment. QR code based mobile payments for security and ease, reduce reliance on cash transactions. Real time monitoring and safety. Enhances workflow efficiency and transparency. Potential for AI based predictive maintenance and IoT integration. Thank you.
This is the hardware setup of our project. This is the power supply which helps to generate the power to the entire board. This is the 4x4 keyboard which used to input the data by the user for the required amount of fuel and send the data to the Arduino for the process. This is the ultrasonic sensor used to measure the fuel level in the tank and ensures the accurate dispensation based on the user input. And this is the IR sensor which helps to detect the vehicle presence. And this is the OLED display which helps to store the important details like QR code and the payment successful status. And this is a motor drive which controls the pump motor speed and direction to ensure the correct amount of fuel to dispensation. And this is the pump motor which helps to transfer the fuel to the tank through the nozzle. And this is the relay module which helps to switch on the solenoid valve, regulate the flow of fuel by opening and closing based on the system instructions from Arduino. This is a Wi-Fi module, enables the communication with a mobile or server for user authentication, OTP verification and remote monitoring. This is the Arduino which sends every instruction to all the components in the hardware part. And this is the GSM module which helps to transmit the data through SIM. Whenever the vehicle approaches to the petrol bunk, sensor detect the vehicle presence, then the OLED screen will display the required amount of fuel quantity in some of the given options. When the user given an input from the keyboard for the required amount of fuel, then the QR code will be generated. When the QR code is generated by the OLED display, the user will scan by the app QR code payment.
After scanning the QR code, the payment interface will be like this. The amount will be default. We select 100 in the OLED screen so that it is 100. And we should enter the mail. I am taking an example like this. Then the card number. Then the expiry date, month, and the year. CVV. Let pay. The payment is successful. After payment is successful, the motor drive will be on. Then here the petrol will be taken from the container and it will dispense to the fuel tank of the vehicle. After the petrol tank is full, the ultrasonic sensor will detect it is full, then it will automatically cut off the fuel. We have used the Firebase to store the data in the cloud. All the real-time data will be stored here. Previously we have seen this, we have done this payment in the mobile app. All this data will be stored in the cloud. Thank you.